What is up, guys? Welcome back to the Marvel Project. And on the last video we talked about vectors. What is a vector? And we saw that it was just anything with a direction and a magnitude. And today we're going to look at a little more with vectors and sort of what you can do and how you can break them down. Alright, so we know vectors with direction and magnitude. Okay, but how do we analyze vectors, or what do we do? What do we do with them? Well, we're gonna look at first some operations that we do with vectors. We're gonna look at two basic operations, and that's addition and subtraction. Okay, or this is really just addition and addition of a negative. So we're gonna look at inversing a vector. Okay, and so all vectors we saw have direction and magnitude. Okay, so say we've got a plane here. Okay, and we have some vectors. Say we have a vector going from here to here and a vector going here. How do we add these two vectors together? Well, what we do intuitively is we take this vector and we put its tail right here at the tip of this vector, and we draw a new vector from the origin to where that ends up. Okay, and so how do we do this computationally? Well, what will happen is we can take the components of each vector. So if we say here this vector is out 10 meters and 10 meters, this is out 5 meters and 5 meters, then we can just take these components and add them together. So what do we know? We know that this 5 is a negative 5 because it's in the opposite direction of this 10. So we add those two together and we get a new vector with an x component of 5. Alright, and what do we have here? We add the y components. This is 5 and this is 10. So you know the y component is 15. So we add the x and the y components and we get a new vector, which is called the resultant vector of this addition. Okay? Now what if we want to subtract? Well, we know, what do we know? We know if we have a minus b, that's the same as a I'll edit this out. So how do we do this? Well, we know if we have a minus b, that's the same as adding a plus a negative b. Alright, and what happens when we do a negative in terms of vectors? Well, we just make all its components negative, and what that'll has the effect of doing is flipping the entire vector over in the opposite direction. Alright, so what do we do now? Well, if we're subtracting two vectors now, so if we have these two vectors, one going from 10 to 10 and the other one from negative 5 and 5, and we wanted to subtract this one from that one, we wanted to subtract the 5 from the 10, we take the 5 and we flip it 180 degrees so it looks something like that, and then we move that to the tail here, and we get the new resultant vector. So what does that look like computationally? Well, say we have a vector. Say we have a vector that has components. Alright, 10 in the x direction and 10 in the y direction. And we wanted to subtract a vector that has components negative 5 in the x and 5 in the y. Alright, so how does this work? Well, we will distribute it, we'll distribute out this negative by this identity, and what that'll give us is the 10, and we'll add, minus, and we'll end up with 15 in the x direction and 5 in the y direction. Alright. And the same works when you get to 3 dimensions.